Okay, I'm going to walk you through sections 11.1 and 11.2, combining them into one lesson because it's going to cover circumference, which is the measure around a circle, and how to measure partial circumference, or what we're going to call arc length. Then we'll move on to the area of a circle, and then work on sector area, so how to find a chunk of a circle, not the whole thing. So circumference and area, you've probably worked on these calculations before. Circumference is defined as 2 pi r, where we're going to use the pi. You can use that feature on your calculator to access pi, 3.14, and then r stands for your radius. Or you can measure circumference as pi d, since 2r, 2 times the radius, represents the diameter. You can also use pi d. So in this example I've given here, 18 feet is given as the diameter. So if you want to just go ahead and use the pi d formula right here, you could go ahead and just say, pardon the truck driving by, 18 pi feet for this example. For chapter 11, I do emphasize the use of units here, whether we have feet, inches, meters. So this is just regular feet, and that would be your final answer. You may want to just do a little notation that your r might be 9 feet to help you out, because now we're going to move on and look at area. Now area, there's no formula that's calculated using diameter, so you do need to know the radius. Since we know the radius is 9 feet, exactly half of the diameter, I'm going to go ahead and plug that in. R squared at 9 is going to bring me up to 81. Let me plug this in. If I plug in 9 feet and I square it, that's going to bring me up to 81 pi feet squared. So you got to get your units right on that one. 81 feet squared. So we want to make sure we have our units correct. Okay, let's look at a second example here. Like I mentioned, these are very much related to circumference and area formulas. It's almost like taking a percentage or a proportion of them. So let's talk about arc length. Now I have a radius for this example of 12 inches. I could use that and use 2 pi r to find the full circumference of the circle. But I want to know just the arc length, just the length from A to B right here. We're going to use this formula to find that. Basically consider that 100 degrees out of a full 360 represents some kind of proportion of the measure of the whole circle. Since a circle is a series of points equidistant around that center, 100 over 360 will simplify that fraction and be able to solve for the measure of this arc. So let's begin. I don't know the measure of the arc, so I'm going to keep that as L AB. The L here stands for length, M stands for the measure. I know that I have 100 degrees over 360 degrees. It's always going to be 360 in the bottom right corner. Now 2 pi r right here, my r is 12. I'm going to multiply that by 2. Let's make that 24 pi inches. I know my answer is going to be in inches since we're measuring the length. It's not a straight line or a straight segment, but it is going to be just straight inches when we get to the end here. I would simplify the fraction on the right side, 100 over 360. You can drop the zeros, and then you can divide by 2, making it 5 over 18. Pi inches. I would then multiply to get length of AB by itself. So 24 pi times 5 is going to go up to the numerator over here. This is going to give me the length of AB is going to be 120 pi inches over 18. Now for these types of problems, because pi is going to be in the calculation, we oftentimes want to get an actual length. You could leave your answer in terms of pi, but let's just say round to a tenth. You can look at the problems and see what they specify and ask you to do. I'm going to use my calculator to find this final answer. So real quick, 120. If you look here on the calculator, you can see that pi is found by using second. Where is it? Up here. It's the second key above your caret there. So 120 pi, and we're going to then divide that amount by 18. So 20.9 inches is what I would round this to. And look back at the example. Again, my drawing's not perfect, not to scale, but I'd say that seems about right for a circle. If it's got a radius of 12 for a 100 degree arc to give about 21 inches, seems about right. So we're gonna say approximately 20.9 inches. Finally, let's do sector area. So this follows kind of the exact same principle. You can see that these two formulas are very close. Really all you have in terms of a change, the right side is exactly the same. On the left side, instead of the arc length, it's the area, and instead of 2 pi r for circumference formula, on the bottom you have the area formula. So to find the area of this sector right here, that's what we call basically the chunk or the slice of the circle we're looking to find. I'm gonna write this as, name it as ACB based on the fact that I have ACB right here. That's how we can name it. Let's just put a little a for area. Pi r squared, we have a radius of 12, so I'm gonna make this 144 pi inches squared. I do want to put the units there for now so I remember to include them at the end. And then once again, the measure of the arc here is 100. Now we already simplified it in the previous problem, so hopefully you would agree that 100 over 360 simplified to 5 over 18 if you want to go ahead and make that shortcut. I'm just running out of space here. So I would solve by multiplying by 144 pi times 5. So to solve this, I'm going to say that 720 pi inches squared over 18 is going to give me my final answer, rounded to the nearest tenth. So this comes out to 125.7 inches squared. So again, you see in the examples above, I kept the answers in terms of pi, and down here when you got a little more specific, I rounded them to a tenth. So just see what each problem type calls for when you're doing the problems. Okay, let me know if you have any questions.